We're going to get started today, and we've got some students who are going to be coming in here in just a moment, and so some students have been detained, and we will be releasing them back into the classroom shortly. Also, for the students in here, they just came off spring break, so we're going to review a lot this hour just to make sure they remember the stuff that they learned a week and a half ago. So about a week and a half ago, we were looking at collections of numbers, for instance, that were organized into vertical and horizontal arrangements. It kind of bracketed off like this. Do we remember what we called this arrangement of numbers and stuff? Maddie? The matrices would be the plural. If there's just one like here, we just call it a matrix. And we'll name this matrix M. And so you name the matrix again based on the letter that is in front of it, a capital letter. And each number that's in the matrix is referred to, Brandon, as an element of the matrix. Good. So these horizontal arrangements are referred to, Abby, as
rows.
There we go, rows. And then these vertical arrangements are columns. Okay, so since this is row 1, column 1, we'd refer to this element, the 3, as element
M11.
Little m, 1, 1. So the capital M names it, but we'll use a little m to notate the element. This then would be, Maddie, M. Well, it's still row 1, column 2. So we'll say 1, 2. So it goes row and then the column. So here would be your M, 2, 1, and this would be M. It took me a minute to say when he said that letter. I'm like, what is she doing? Oh, that's right. Okay, sorry. I've had a week and a half off.
1, 2, 2.
This would be 2, 2, and then this would be M, 3, 1, and then M, 3, 2. There we go. There's our different elements there. How would I define the size of matrix M? Not, well, it's little or it's big. How would I define the size of matrix M, Brandon? Good, it's a 3 by 2 matrix. 3 rows, 2 columns. So when we define the size, remember it's always rows and then columns next. And size matters as far as a matrix or matrices is concerned when it comes to adding matrices. You can't add or, quote, subtract matrices, Abby, unless they are
the same dimension.
The same dimensions or the same size, right? So if I had another matrix, we'll name this one A, and maybe it's, a very, anyway, I'm lacking creativity today. So there's our matrix A. Well, because it's also 3 by 2 like this one is, I could add the two matrices together. What would I get if I added them, Abby?
4, -3, 6, -6, and -1, 2.
There we go. That would be the sum of the two matrices. We just add the corresponding elements together. If I were to subtract, well, we never really subtract in algebra, Maddie. We have the inverse. So the same is true here. If we were to try to subtract matrix A, well, we'd actually add what's called the additive inverse. And the reason is there's also a multiplicative inverse. We'll talk about it in a couple days. What would be the additive inverse here of A? Good. And so if we were to subtract, well, really that means add the inverse of A. So what would be M negative A, Matt?
2, -5, 4, -8, -3, 0.
There we go. So M minus A, just change all the signs of A and then add the two matrices together. We talked about multiplying by a constant. For instance, if I said 4M, well, this would be multiplying matrix M times a constant value 4. Do you remember the name for that constant value?
I do not.
Anyone remember? It's been a little while. It's called a scalar. So scalar multiplication involves multiplying a constant value by every element in the matrix. So what would be 4 times matrix M? Back to Brandon.
12, -16, 20, -28, -84.
Good, exactly what we picked. So nothing hard about scalar multiplication whatsoever. We just distribute the 4 in a sense to every single element. All of this we covered the very first day, and I feel like we had it really well done. Do we remember this now that we've gone over it? All right, let's do a little bit of practice. Page 274 in your books, and then we'll get to the more complicated stuff we did in our last lesson. Though, at the end of the lesson, I felt like we still were doing okay. So I think we'll be fine, but we'll spend a little bit more time there. Page 274 to 275, I want you to do 10 to 18 the even. 10 to 18 the even. These should be pretty quick and easy. All right, let's go and take a look at these number 10. Really straightforward, just adding them together. Brandon?
Negative 26, 10, 6, 77.
Good. Again, that's negative 26, 10, 6, 77. Number 12, what did you get for your answer, Maddie?
41, 26, 10, negative 53, negative 6, 2, negative 3, 29.
Great job. Again, for the camera, that is 41, 26, or 26, I was right the first time, 10, negative 53, negative 6, 2, negative 3, 29, and 23. Good to go on 10 and 12. All right, number 14, just change all the signs, right? Negative 23, positive 9, 44, 34, negative 12, 2, negative 51, negative 98. All right, number 16. When we added the inverse, what did we end up with for our answer, Abby?
57, 14, 26, 40.
Good, 57, 14, 26, 40. And then for number 18, Brandon.
Negative 42, 11, negative 64, 72, 33, 33, 67, 35, 26, and 0.
Good, negative 42, 11, negative 64, 72, 33, 67, 35, 26, 0. Are we good on all 5 of those? All right, Number 20 and number 22, scalar multiplication. Very quickly, do both of these. 20 and 22, they're on page 275. And what did you get on number 20, Maddie? Good. Negative 25, negative 10, 150, 0, 5, negative 30, 100, 55, negative 45. And then number 22, that 2 by 4 matrix, when we distributed or multiplied that negative 2 scalar. Abby?
10, negative 12, negative 14, 16, 4, negative 2, 0, negative 16.
Great job. Again, that's 10, negative 12, negative 14, 16, 4, negative 2, 0, negative 16. Going to go on both of those, I assume. All right, now for 24 and 26. Kind of put all the different processes together. Juniors and seniors will quietly come on in. We're working page 275, numbers 24 and 26. So practicing with scalar multiplication, addition, subtraction of matrices. I'm going to send you all the link to the video if you wanted to watch it later this evening. You missed about the first 12 and a half minutes or so. If you feel you need the review, a lot of terms reviewed that you might be benefiting from, but nothing new that we've gone over. Here we're on page 275 doing 24 and 26. right, for sake of time, I know those who just came in have not had time to work it. I'm going to have you work it along with me now, though, as we go over it. Kendall, on number 24, it wants us to take negative 5b minus a. And remember, in order to add or subtract matrices, they have to be the same dimensions, and they are. All three matrices, A, B, and C, are 3 by 3 matrices. So negative 5, when we multiply that scalar times the B matrix, what does the B matrix become? What is negative 5b?
Negative 5, 10, negative 10, negative 25, negative 60, negative 20, 40, 0, negative 75.
Good, and then it says minus a, but we never really subtract in algebra. We always add the inverse, and as I mentioned earlier on video, we add what's called the additive inverse. So we're actually going to copy down negative a. Michael, what do we write down for negative a?
3, 11, and negative 11, negative 6, negative 20, 8, negative 1, 0, 10, negative 4.
There we go, we just change all the signs, and then we add them together, Genesis, and what should we get for the sum matrix? Remember, here we're just going to add the corresponding elements.
Negative 2. Negative 1. 9. Negative 45.
Coming off spring break, calculator's a great friend, isn't it? It's all good.
19.
Ooh, they're both negative. So add and keep the sign.
21.
Negative 21, there we go.
40. 10. And negative 79.
Good. There we go. And how many have this answer for number 24? Again, those who were here earlier should have, and then some of you came in and were able to finish. Number 26, it asks you to find 6, B negative C. Again, order of operations, what do I have to do first, Audrey?
You have to subtract the 2.
I have to subtract them, B minus C. Since this is the last problem that uses them, no problem in your book changing all the signs of C. Let's figure out what is B minus C as we go through here, Audrey.
20, 30, negative 1, negative 3, 1, 25, negative 3, negative 9, 16,
Well, you're subtracting it.
negative 16, 20.
There we go. Really good. All right, and then we just multiply the scalar of the 6, and Abby, what did you get?
138, negative 6, negative 18, 6, 150, negative 18, negative 54, negative 96, and 120.
And again, very nice to have a calculator for this section. Not sure if she used one or not, but that is our correct answer. And did you guys get that? And I don't believe any of you had time to finish. You did have time to finish. Wow, impressive. All right, questions on this. This was, I would say, the easy stuff that we did the first couple of days. And then we did something different the next day. And all of you, by the time we were done with the lesson, all of you understood it, but coming off spring break, this is the thing I wouldn't expect you to remember how to do. So let's spend some time reviewing over this next thing. That's matrix multiplication. Quick refresher, some things that you see right there on the poster, but they bear repeating anyway. In order to multiply matrices, they don't have to be the same dimensions, but what I like to call the inner dimensions have to match. That is, the number of columns of the first matrix has to match the number of rows in the next matrix. Do you remember that? That vaguely sounding familiar? These inner dimensions have to match. The outer dimensions actually tell you what your product is going to be. So here I have a 3 by 3 matrix A. I've got a 3 by 2 matrix B. Because this has 3 columns and this has 3 rows, I'm able to do the multiplication. My answer, though, is going to be a 3 by 2 product matrix. Okay? So remember, I said this before, you can't multiply B times A. Only A times B. Oftentimes, multiplication is not commutative. That is, you can't just reverse the order necessarily. Look at page 282 with me now, if you would, please. Page 282. And one of the first things we worked on in our last lesson, which again, for the students in here, that was a week and a half ago. So Don't judge if you're watching on YouTube. But a week and a half ago, one of the first things we worked on was just telling whether or not we could multiply matrices. Look at page 282, number 2. What are the dimensions of the first matrix in number 2? Maddie?
3 by 0.
Well, it's not 3 by 0, 3 by... It's a 3 by 1, and then the next matrix is, Brandon, a 2 by 2 matrix. Can I multiply these two matrices, class? No. Can't multiply. We move on to the next one. Number 4. What's the dimensions of that first matrix, Kendall?
A 1 by 2.
On number 4?
Oh, no, A 1 by 4.
It's a 1 by 4 matrix. By the way, what do we call a matrix that only has a single row, class? Row matrix. And, for instance, anyway. Number 2, by the way, this was a single column. We call it a column matrix. By the way, the second matrix, the 2 by 2, since it has the same number of rows and columns, we'd call that a square matrix. Okay, but a 1 by 4 row matrix. What's the next matrix dimensions, Michael?
4 by 3.
It's 4 by 3. Can I multiply these two matrices together, class? Yes. What would the product be if you multiply a 1 by 4 by a 4 by 3, class?
1 by 3.
It'd be a 1 by 3 product when we're all said and done. What about number 6? The first matrix, Genesis, is a... Good, a 3 by 1. And the second matrix, Audrey, is a 2 by 1. Can I multiply them, class? Nope. Number 8, first matrix, Brandon?
2 by 2.
Maddie, second matrix.
2 by 4.
Can I multiply these, class? Yes, what's the product going to be? It's going to be what?
2 by 4.
2 by 4. Good job, Brandon. The rest of us know that as well. Just letting him answer on behalf of the class spokesperson. You answered too? I'm sorry, I just couldn't hear you. All right, number 10. The first matrix here, Abby, is a...
3 by 1.
Hey, I heard you. The next matrix is a...
3 by 2.
3 by 2. And the next matrix is a...
1 by 3.
1 by 3. Can I multiply the first two together? Can I multiply the next two together?
No.
No. Yeah, now what if I put this in the middle? What if I rearrange them? Then I have a 3 by 1, a 1 by 3, and a 3 by 2. Could I multiply those? Yeah, so it's not that the matrices couldn't be multiplied, they just couldn't be multiplied in that order. And by the way, when you multiply the first two, what would the product matrix be, class?
3 by 3.
3 by 3. And then I multiply that by the 3 by 2. Again, I'm still good to go. And my final answer would end up being a 3 by 2. But only if I took the last matrix and put it in the middle for the multiplication. Do we remember this from our last lesson a week and a half ago? Remember the whole multiplying thing, the way the dimensions got to work? All right. Now, let's review the actual process. In your notes, you should have something along these lines. Make sure it's written in there. You multiply each row of the first matrix by each column of the second. Multiply each row by each column. Do you have that in there? As you multiply row by column, you're going to get what are called partial products. We have to add the partial products together. And the sum actually gives you the elements. So write this down and do this with me if you would. 3, -1, 5, 0, 4, 2. We're going to start with this matrix. 3, -1, 5, 0, 4, 2. We're going to multiply this, raised dot, by 7, -3, 4, 6. Again, the first matrix, class, is a 2 by 3, and the second matrix is a 2 by 2. Can I multiply these? No, that's not going to work. Let's modify this slightly. Let's add an extra row. Let's make this a 1 and a 0 on top. So now my second matrix, class, is a 3 by 2. Now can I multiply them? Yeah, I just needed to have 3 rows. I needed to have as many rows here as I had columns here. What is the sum, or the product matrix rather, going to be, class? 2 by 2. So remember what I recommended in the last lesson is draw a nice big matrix and give yourself 2 rows and 2 columns. this first matrix, this first element here, is going to be the sum, this sigma, by the way. I don't think I explained this in the last lesson. My brain just in autopilot on that last day before spring break. Those in geometry already knew this, but those who weren't might not recognize it, maybe from science class possibly. This sigma symbol means sum. How many have seen that before? Okay, anyone you're like, I've never heard that before. Okay, it's okay, not a problem at all. This sigma symbol means sum, so the sum of whatever. So in this case, we're going to take the sum of all the row 1 of the first matrix, column 1 of the second matrix partial products. So we're going to take this row and this column, and we're going to multiply top times first, middle times middle, last times bottom. Okay? So we're going to multiply. Well, my first partial product class is 3 times 1. Then negative 1 times 7, and then 5 times 4. Those are all my partial products. This here is going to be the sum of, we're still in row 1, aren't we? But it's going to use column 2. So I'm going to take this same row, I'm going to multiply it by this column now. But again, it's going to be first times top, middle times middle, last times bottom. So what are my 3 partial products going to be here, Audrey?
0, 3, 30.
There we go. And we're going to add all those together here in just a moment. Then we come down here. Well, this is row 2, column 2. So we're going to take the sum of all the row 2, column 1. We're going to take the sum of all the row 2, column 1 partial products. So now I'm looking at this row. I'm going to multiply all of these terms in the bottom row by the first column. So again, it's going to be first times top, middle times middle, last times bottom. What are those 3 partial products going to be? Maddie? Good, 0, 28, 8. And then finally, I'm going to take the sum of all of my row 2, column 2, because this is element 2, 2. 1, 1, 1, 2, 2, 1, 2, 2. And so we're going to take this, and we're going to multiply everything down this column. Again, first, middle, last. What do we get as we multiply here, Kendall?
0, negative 12, and 12.
Good, but again, we're going to take the sums of these partial products. So again, 0 times 0, 4 times negative 3, and 2 times 6. All right, then we're going to add them all together. So my final answer, I'm going to add all of these together, and what do I get for the first term of the matrix class, the first element?
16.
A 16. What's the next element going to be, class? 33. Then in the second row, I'm going to have a 36 followed by a 0. Now that we've seen it again for the first time in a while, how many say, okay, I kind of remember doing this. I wouldn't say I'm ready to do one on my own yet, but I kind of remember doing this from a long time ago. All right, some of you still need to see another 1 or 2. Let me say, I'd still like to see another 1 or 2 more. I mean, like, I'm just too tired to raise my hand. I just came off spring break. I'll just like that. All right, page 283. Let's copy down number 19. Copy down number 19 onto your paper. And we've got a little 2, 2, and a 2 by 4. Again, one of the first things you'll do on every multiplication is ask yourself, can I? Class? Yeah. Then you'll ask yourself the question, what am I going to get when I multiply? Answer?
2 by 4.
You're going to get another 2 by 4. So you're going to give yourself enough room for 2 rows, 1, 2, 3, 4 columns. The key here, multiply each row by all columns. Each row by all columns. So start with the first row, multiply by 1 column, 2 column, 3 column, 4 column. Let's go to the first column. What are my partial products going to be here, Michael?
First column, negative 1 and 15.
Good, -1 and 15. Then we go to the next column, and we multiply here. What do I get from my partial products now, Genesis?
0 and -2. Oh,
So remember, the 1 gets multiplied here, and then the -5 there. So 0 and 10. It's okay. Take the third column. Now, same thing, Genesis, first row, but now the third column.
-15.
Perfect. All right, and then Abby, the last column.
-4, 0.
Ooh,
No, 4, yeah, 4, 0.
just 4, 0. There we go. Not a negative, just 4, 0. All right, then we're done with the first row. Notice my entire first row is filled. That means I'm done with my first row. Now I'm going to go to the second row, and I'm going to go to the first column. What are my partial products? We'll stay with Abby.
In the book, 19, that's a -4.
Did I copy it wrong? What are we, 19? Oh, okay. That'll help to match what the book has. Now that oh yeah, the book does give me an answer. How about that? Isn't it giving me answers on most of these? It's great. Okay, so let's go with a -4 and a 0. How about that? We like that better?
Yes.
Okay, thank you, Abby. All right, let's go to the next row, the 2, -4, and let's go to the first column. And Abby, what do we get?
-2, 12.
-2, 12. All right, Brandon, let's go to the second column, still working on the bottom row.
0, 8.
0, 8. And the next one, Kendall.
10 and -12.
And then finally the last one, Maddie. -8, 0. All right, what do I do to go from all of these partial products to the actual product that is my answer? Genesis? Add all the little boxes together. Again, that's assuming you took the time to make little boxes. All right, so what's my top row going to be, Michael?
14, 10, -10, 4.
And I think we ended up saying it was a -4 because we had put a negative there, thanks to Abby. And what about the bottom row, Genesis?
10, 8, -2, 8.
There we go. And since the book actually was nice enough to give me the answer for this one, we can check it. It is correct, thanks to Abby. How many got this here? All right. How many say, okay, I think I got it now? Anyone's still like, nah, can we do another one? Michael's just like, I refuse to raise my hand. When I got muscles this big, they weigh so much, I just can't bring myself to do that weightlifting when I'm not actually in training. Let's do one more anyway. Let's do number 17. Number 17. Look at the easy ones with you and then give you a great big one to do on your own. How about anyway, all right. Should I copy it correctly this time? First question I should ask myself anytime I see a multiplication problem. Can you? In order to answer that, I need to identify the dimensions or the size of the matrix. The first one and the second one. Can I? Next question should always be, what's your product? How big is the product? What you gonna get? And how big is my product going to be, class? It's going to be a 1 by 2. So I only need a single row, and I only need 2 columns. It's going to be a little bitty guy. All right, what do I do to figure this out? Michael?
You multiply the row 1 by column 1.
Row 1 by column 1. How many partial products am I going to get?
4.
4. Whatever the matching dimensions is, that's how many partial products in each box, by the way. You don't have to memorize that fact, but it's just how it's going to be. What are my partial products, Michael?
15, 0, -9, 3.
All right, and then what am I going to do, Audrey?
Gonna do the other one.
Same thing, same row, but do it with the other column now. And what are those partial products, Audrey?
-3, 32, -4, 11.
All right, and then finally to finish it out, what do I got to do, Brandon? Add them all together. And what's my little bitty matrix going to be? I don't know yet either. Hold on.
9, or 6.
And there we go. All right, ready or not? Here it comes. I think we're ready. How many we feel like we're ready? I'm not sure. Question? Okay, I want you to do number 15. Number 15. It's square matrix, so you know they're going to work 3 by 3, 3 by 3. You won't get a 3 by 3. Okay, but do number 15 there at your seats. Set up a little tic-tac-toe grid, but don't play tic-tac-toe. Okay, right. So we're going to take this row. Multiply it here. The first times the first gives the first. Now do second times second. Third times third. And then fourth by fourth. Now we're going to do the same thing again. We're going to take the same row. We're going to go down the second column now. First by first. Second by second. Third by third. Fourth by fourth. Does that make sense? Okay, so remember, these two numbers tell you that you can do it because they match. These tell you the dimensions. It's going to be a 1 by 2. Yep. Are you done already? Show off. Hey, I can actually check your answer. I was about to say, I'm not going to know if you're right or not, but I can. They give me the answer. Again, the beauty of square matrices, as long as they're the same number of squares, you can always multiply and you're always going to get the same thing as the others. So that takes a lot of the suspense out of it. You need 3 rows, you need 3 columns. Brandon's done, Abby's done. Kendall's finished. Some of you are thankful you worked on mental math when you were younger. Some of you are thankful for calculators. Some are thankful for both. The numbers on this one weren't too bad. Kendall, what's your first box of partial products?
0, 6. No.
Oh, row times column. So you're right about the 0, but we're not going sideways to 6. It's going 0.
-3. -4.
Very There we go. Okay, so what should the second box be?
2, -6, 0,
There we go. And then the third box.
1, 3, and -6.
There we go. Does that make sense? All right, let's go to Michael. We're working with the second row now, going down the first column. What are my partial products?
0, 0, 2.
All right, the next box.
Negative, or hold up, is that a negative? I gotta see what I wrote down. I'm confused by my second one.
Okay, we're taking this row and multiplying by this
0,
column. 4, 0, 0. And then the last box in this row,
2, 0, 3.
2, 0, 3. All right, Genesis, what's this box going to have for me as we go to the third row, first column?
0, -5, -2.
Good, the next box.
8, -10, 7.
And the last box.
4, 5,
And Audrey was the first one done. Audrey, when we combine all the partial products together, what do we get?
-7, -4, -2, 2, 4, 5, -7, -2, 6.
And that is correct. And how many got that answer there? Okay. Questions? Obviously, we figured out what you did. All right, so we're good to go now. Maddie, where were you at? I don't know if you finished or not, but were we on the right track?
I'm finished, but didn't have those numbers.
Okay. Checking your partial products. Did you have these partial products in the first row? Just check that row for now.
I changed them, but I somehow when I multiplied, I didn't get those numbers.
Okay, let me do this. Let me erase the bottom row of partial products and go over those with you again real quick. Just make sure we've got the handle on it before we get into the homework tonight. So remember, for this row, we're going to take the bottom row, the third row, and we're going to go one column at a time. So for this first column, remember, it's going to be these get multiplied. So we get,
0, 5, -2.
right, and then for this next row, we're looking, again, same row, rather, next column.
8, -2, 0,
Okay, and then finally we go to the third column, still staying with the third row.
4, 5, -2.
All right, do you see it now? And then Kendall, ditto, you see it now? Okay, good. Any questions? You're going to have 3 of these in your homework tonight. Page 283. Page 283. Numbers 12, 14, and 18. Page 283, numbers 12, 14, and 18. And then also some additional review over the original things I taught in the very first lesson, the easy stuff, but bears practice. Page 285 to 286. Pages 285 to 286, 14 through 22 even. Page 285 to 286, 14 to 22 even. And again, those of you who came in a little bit later, I'll be sending you the video, especially if you struggle on the 14 to 22 even, watch the video. But there's some terms that get reviewed in there as well. It might benefit you to watch this from the terms side of things. All right, we'll continue tomorrow and make a little new headway tomorrow as well in our next lesson. When the bell rings, you'll be dismissed.